Yes, very good morning. Very good morning, Raunak, Babai, Ankit, everybody who are present in my class today. Can you hear me? Am I audible? Okay. So today we will repeat the class which I took yesterday, and we will again discuss the same things. Then I shall give you the questions in Google Classroom. And many of you asked me how to join Google Classroom. The method is very simple. You have to download the app Google Classroom from Google Play Stores. It is absolutely free. So you have to download the app. Then what you have to do, you have to sign in with your Gmail account. If you do not have your Gmail account of your own, then you can use your parents' Gmail accounts, and then it will lead you to the classroom. Then you will find there is an option to join class. You have to click join class. Then when you will click the join class tab, it will ask you for class code. This class code will be provided by the teacher. I shall give you the class code. So what you have to do, you have to put the class code there, and then you have to click join class, and you will be automatically joined within the Google Classroom. When you will enter the Google Classroom, you will find the assignments is there, the questions is there, the questions are there. So what you have to do, you have to go through the questions. Then the question comes how you will submit the answer. So what you have to do, you have to write all the answers in your exercise copy. Once done, just click the photos of your exercise copy where you have written the answers and upload the same to the Google Classroom. Once you do, then I shall check all the answer scripts, and I shall also put the comments that whether it is all okay or whether you have to change something or whether you have done anything mistake, and I will correct it, and I will also submit the same, so that you will get the information and you will go through all the check papers. So this is the process by which you have to use the Google Classroom. Never send me anything to my WhatsApp number, because in WhatsApp all the messages get flooded. So what happens, I cannot trace the exact answer from you. So Google Classroom is the best way to keep your answers there. I have created all the classes, for example class 6 to class 12, and they put all the answers there. Okay, so is it clear to you? Is it clear? Okay. Yes, I have also found that it is lagging. Let me fix it. I hope it is fixed now. Okay, so let's start the class today. In fact, I am repeating the old class, the class which I have taken yesterday. I am repeating that. Okay, so let's start this class. So yesterday I taught you regarding bases and alkalis. So what is a base? Yesterday I told you that, just a minute, just wait. So what is a base? Yesterday I told you regarding what is a base, and just it was the definition that a substance which produces hydroxide ions in aqueous solution are called bases. These substances are used to neutralize acid. So what is a Yes, now it is corrected. Okay, so let's start this one. What is a base? A base is a substance which produces hydroxide ions in aqueous solutions. For example, if you put something in a liquid, then and if it produces this ion, for example this hydroxide ions is produced, then it is called base. So any substance which you put in water or in any aqueous solution, and if it produces hydroxide ions, what is the symbol of hydroxide ions? This is OH negative. This is a negative ion. And if it is produced when it is put in water or in aqueous solution, then we call it a base. Now these substances are actually used to neutralize acid. A substance, and in case of acid, what you have read, that any substance which produces hydrogen ions in aqueous solution is called acid. So what is the difference between acid and a base? A base produces hydroxide ion in aqueous solutions. A base produces hydroxide ions in aqueous solution, whereas an acid is a substance which produces hydrogen ions in aqueous solution. So this is the basic difference between acid and base. Okay. Now can you tell me the examples of bases? There are lots of examples of bases. For example, zinc hydroxide, calcium hydroxide, sodium hydroxide, etc. are all the examples of bases. Now what happens? Base reacts with the acid in order to make it neutral. Actually what happens is this: if base reacts with acid, then it forms salt and water. Now let's see the properties of bases. Okay. So what are the properties of bases? Yesterday you learned these things. The base is bitter in taste. Okay, the base is bitter in taste. So if you taste any base substance, then you will find the taste is bitter, and if you taste acid, then you will find that it is sour in taste, and it is also slippery in nature. For example, if you touch any base substances and if it comes in contact with water, then you will find that it becomes slippery. That means it is almost soap like. The soap is slippery, it is also slippery, and they turn litmus paper into blue, and in case of acid you have learnt that blue litmus paper turns red. So here they turn red litmus paper into blue. That means it's just the opposite. It is a very good, it is a good conductor of electricity. For example, electricity passes through base substances or alkali substances pretty well, and they produce salt molecules and water when reacts with acid. For example, sodium hydroxide, for example sodium hydroxide reacting with hydrochloric acid. So what is the formula of sodium hydroxide? NaOH, and then what you will write? What is the formula of hydrochloric acid? HCl. Then what will the products will be produced? Sodium chloride, NaCl, and there will be also water. So this is the property where they produce salt molecules and water when react with. Yes, I am repeating the class again. Yesterday many of you didn't attend the class, so for them I am repeating this class. So what I told you just now, that base substances, what they do, they react with water and they react with acids to form salt and water. For example, I told you that sodium hydroxide is reacting with water, and what is sodium hydroxide is reacting with acid. For example, hydrochloric acid, and what is it is forming? It is forming sodium chloride and water. So this is one of the properties, and when it reacts with ammonium salts, they produce ammonia. For example, here you find calcium hydroxide is reacting with ammonium chloride, and what it is forming? It is forming calcium chloride, ammonia and water. So here you can find in this reaction, it is clearly shown that calcium hydroxide is reacting with ammonium chloride, and it is producing calcium chloride, ammonia and water. And what is the pH of any basic or any alkali substances? They are more than 7. It is showing here, it is greater than 7, and if it is less than 7, what we will call it? They are acidic. So lesser the pH, more acidic; greater the pH, more basic or alkaline. Is it clear to you? Is it clear? Okay. Now next we will learn types of bases. What are these types of bases? More pH, more basic, right Ankit, and less pH, more acid. Now we will learn regarding the types of bases. So let's see the types of bases. Now there are two types of bases. One is called very strong base, another one is called weak base. Now what are strong bases? The bases which have high numbers of hydroxyl ions. You have just learned that bases are any substances which produce hydroxide ions or hydroxyl ions when it comes to aqueous solution, when it comes in contact with the aqueous solution. So strong bases have high number of hydroxyl ions, and weak bases have less number of hydroxyl ions, and strong bases have more pH, whereas the weak bases have lesser pH than the strong bases. So here is an example of strong bases. Sodium hydroxide, NaOH is sodium hydroxide, and weak base is ammonia. NH3 is ammonia. Okay. Okay, Ongshuman, where will you get the litmus paper? You will get it in any chemical shop. If you go to any drugs and chemicals or lab instruments, you will be able to purchase litmus paper. Any shop which sells scientific tools and devices, there you can easily purchase or buy litmus paper. So I hope this is clear that bases are of two types. One is called strong base, that is sodium hydroxide. Another one is called weak base, that is ammonia. Strong bases produce more hydroxyl ions and weak bases produce less hydroxyl ions. Strong bases have more pH and weak bases have lesser pH than the strong bases. So next go to the next one. Now let us see what are the common bases and its uses. Yesterday I didn't tell about this, and later I thought that this you should know that the uses of bases in our daily life. What are these? Okay. Now you see sodium hydroxide. This is also commonly known as caustic soda. Okay. Now you know we have the kitchen chimneys, and these kitchen chimneys, what do these kitchen chimneys do? They draw the oil from the cooking. Okay, so they draw the oil from the cooking, and what happens? This oil gets stored or gets deposited in the basil filter. So you have to clean the basil filter from time to time. You have to clean them periodically. So to clean them, what we do, we just remove the basil filters and put them in a bucket containing water, and we pour caustic soda there. Why we put caustic soda there? Because it removes the greases and oils. So it removes the greases and oils from the basil filters and make them oil free, so that we can again reuse them in our kitchen chimneys. So this is one of the uses. Okay. Okay. Yes, baffle filter. Yes, baffle filter. So what we do, the baffle filters draw the oils, and get all these oils get stored there. And what we do, we just remove those baffle filters and we put them in a bucket containing water, and within that water we put caustic soda. And this caustic soda, and we keep them for half an hour, or say for example 1 hour, we keep them like that, and it removes all the dirts, all the greases, all the oils, and then we dry them and we again put them in our kitchen chimneys and we can use it again. So this is one of the uses of sodium hydroxides. It is also a very good drain cleaner. So what happens is this, the sink or the basins get clogged from time to time. So if we put caustic soda there or sodium hydroxide there, it dissolves that clogs and again starts the running of water through them. Then the second one is caustic potash. So this is one of the ingredients which we use. Yes, Ankit. Then again we use this for making liquid soaps and soft soaps, and we also use in alkaline batteries. So this is the use of caustic potash. So what we do, we use in making liquid soaps, soft soaps and alkaline batteries. Then the third one, magnesium hydroxide. The formula of magnesium hydroxide is MgOH2. And what is the use of magnesium hydroxide? This is also commonly known as, yes, caustic sugar, not that is caustic soda, not sugar. caustic potash, not sugar. Now next is milk of magnesia, that is magnesium hydroxide. Magnesium hydroxide, what is the function of magnesium hydroxide? It acts as a laxative, antacids and deodorants. It is also used to neutralize acidic wastewater. Next is the calcium hydroxide, or this is also known as slaked lime. Now it is used in manufacturing cement and lime water. It is also used to neutralize acidic soil. So this is the function of calcium hydroxide or slaked lime. And what is the function of aluminum hydroxide? It is also acts as an antacid. It purifies water and acts as an antacid. Okay. What is a laxative? Laxative is a substance which helps in our bowel movement or remove the feces or the stool from our body. Now ammonia, this is a building block of the synthesis of many pharmaceutical products. That means many medical products we use ammonia as ingredient. It is also used for cleaning various substances, and it is also used for making many fertilizers. So these are all the uses of common bases. So just take a screenshot of this one. Okay, take a screenshot of this one. So this will help you. Have you taken? If you have taken, then I will go to the next slide. Now, yes, many fertilizers consist made up of ammonia. There is ammonia in them. Okay. Now, what is alkali? Yesterday I told you that alkali is a base which is dissolved in what? In water. Just a minute. So what is an alkali? Alkali is any substance where base is dissolved in water. Again there is streaming problem. Okay. Now, here you find alkali, this word has come from an Arabic word, alkali. Alkali means ashes of salt wort. Alkali, ashes of salt wort. Salt wort means alkali. It means salt of water. No, salt wort, I have just, it is a plant. Plant of the goosefoot family which typically grows in salt marshes. It is rich in alkali and its ashes were formerly used in soap making. Is it clear to you? Is it clear? Yes, the word comes from Arabic words alkali. Alkali came from alkali, A-L-Q-U-A-L-Y, alkali. Okay. So, alkali is a base that dissolves in water. Only this much you learn. Alkali is a base that can be dissolved in water. So, if someone asks you that what is the difference between base and alkali, you will say that it is a base which can be dissolved in water. The base which can be dissolved in water is nothing but an alkali. Okay, so it is clear, I think. So we are going to the next slide. Next, are the properties of alkali. Now you have written the properties of bases, isn't it? You have written the properties of bases earlier. You will write the same properties. You will write the same properties for alkali. Just you will add one more thing there. What is this? That alkali dissolves in water but bases don't. So you will write all the properties of bases, and with that you will add that alkalis are bases that dissolve in water. So you have to write only this much. You have to write only this much. Okay, so it is clear? Is it clear? Okay. So there may be a question that what are the differences between alkali and base. Yesterday I showed this slide to you, that bases do not dissolve in water and alkalis are bases that dissolve in water. All bases are not alkalis, but all alkalis are bases. All bases are not alkalis, but all alkalis are bases. So why we are telling this one? All bases are alkalis, but all alkalis are not base. Why? Now look at this slide. Bases may either be soluble or insoluble in water. Therefore, all alkalis are bases because they will all neutralize acids. But not all bases are alkalis because not all bases will dissolve in water. An example of an alkali is sodium hydroxide. If you put sodium hydroxide in water, then it will easily get dissolved. Which bases are not alkalis? Next question comes, which bases are not alkalis? For example, copper oxide is a base that you cannot dissolve in water. That means copper oxide is a base and you cannot call it an alkali. Is it clear? Because you cannot dissolve copper oxide in water. Sodium hydroxide is an alkali because it gets easily dissolved in water. Yes, sodium hydroxide is an alkali because it gets easily dissolved in water. You just purchase caustic soda from market and get them and put them in water, you will find that it will get dissolved. Okay, but if you bring if you bring copper oxide and put them in water, you will find it is not getting dissolved because it is a base. So for that reason I have told you that all bases are alkalis, but all alkalis are not base. So if the question comes, then you can easily write it now. Is it clear? So that's the reason why I have told you that all bases are alkalis, but all alkalis are not bases. Okay. Okay. Now, if someone asks you, how will you understand that this substance is base or this substance is acid? So, for that you have to use your indicators. You know, indicators are there in your book, concept of indicators. So, indicators are nothing. They indicate the color of a substance, whether it is acid or whether it is base or alkali. Is it clear? So, indicator is nothing but it is a substance. It indicates whether the substance is acid or whether that substance is base or alkali. For example, this is the universal, this you see at the top of this, at the top of the pictures. The red one indicates the acid. The green one indicates neutral. That means it is neither acid nor base nor alkali. That is, if you put any red litmus paper, it won't change. If you put any blue litmus paper, it won't change. That means there will be no change in the middle. For example, if you put litmus paper in water, will the color change? The answer is no. If you put the blue litmus paper in water, will the color change? No, because water is a neutral oxide. So, it is neither acid nor base nor alkali. So, this is indicated as green, and this is the violet color or indigo color. It indicates the alkali or base. That means here, if we go to the left side, it is less pH. If we go to the right side, more pH. Then we are using phenolphthalein. If we use phenolphthalein, then we will find there is no change in acid. The color of the phenolphthalein will remain same, but it will turn pink if it comes in contact with base. Yes, if it comes in contact with base or alkali. So, if you put phenolphthalein in base or alkali, it will turn pink. Okay. Methyl orange, if you put in acid, it will become red, and if you put them in base, it will remain orange in color. Okay. And another one, if you put thymol blue, then it will be blue in presence of in presence of base or alkali, and it will be red in presence of acid. And then bromothymol blue will turn base to blue and yellow in presence of acid. And phenol red, it will turn pink or magenta color in presence of base or alkali, and yellow in presence of acids. And you also know, if you put red litmus paper, it will turn blue in case of bases or alkalis. Okay, Ankit, what is universal indicator? It is a mixture of dyes that changes color gradually over a range of pH and is used in testing for acids or alkalis. So, it is a mixture of dyes that changes color gradually over a range of pH and is used in testing for acids and alkalis. So, only 9 or 10 students are there today. This is very unfortunate. I repeated the class and still If such thing happens, then this is really unfortunate. Hope in the next class there will be more students. So much for today. I have already finished this topic, and next week we will learn something new. So I hope you have all understood today's topic and there is no problem with this topic. Okay, very good. So stay safe, stay well, and enjoy Sunday. Actually, we have all Sundays every day due to this COVID-19. So have a great day and goodbye for now. I am ending the streaming. Bye bye.